Okay, let's try a log question. I have log base 2 of 2 minus x plus log base 2 of 1 minus x equals log base 2 of x plus 4 plus 1. Why is this a scholarship question, you ask? Well, first of all, it's got 3 logs. And people don't like it when there's 3 logs. There's a lot of log rules to deal with. And it's an equation. People don't like the fact that it's an equation, and it's log base 2, so our calculators can't really help us. So what we're going to do is we're going to try to figure out how to use our log rules to solve this question. First of all, I would probably put all of my logs to one side and try to combine them as a single log. So let's start there. I have log base 2, 2 minus x, plus log base 2 of 1 minus x, minus log base 2 of x plus 4 equals 1. So I moved them all to one side of my equation. Now let's see if that would actually help us. So I moved all to one side of the equation. I'm now going to try to combine them as a single log. The first two are being added, and adding, when we use our log rules, means we're going to multiply those two together. And the third one is being subtracted, which in log rules means we're going to divide it. So now we have a single log on the left and a number on the right. Let's see what we can do with that. We are going to take this equation and try to get rid of the log. We are going to use our rule of 7. We have our base, exponent, and answer. So I'm going to rewrite this side. And my base is 2, my exponent is 1, and my answer is what I have on the left. Now this becomes an algebra question. How do we solve an algebra question with a fraction in it? I'm going to multiply both sides by the common denominator. When I multiply both sides by the common denominator, it allows me to cancel my fraction part. That is very helpful when we are solving a question. So on the left-hand side, I am now going to have something I've got to FOIL out. And on the right-hand side, I'm going to distribute through that 2. Once I get to this part of the equation, my plan is to move everything to the left-hand side and set it equal to 0. Once I am here, my plan will be to either try to factor, use the quadratic formula, or to graph it. What two numbers multiply to negative 6, but add to negative 5? X equals negative 5 and plus 1. What value of x will make the first bracket 0? 6. And what value of x will make the second bracket 0? Negative 1. Now, I could have also solved that using my graphing calculator. I type in x squared minus 5x minus 6, and I'm trying to find the zeros. There's the graph of my function. I'm going to go to the left of where it crosses the x-axis. That's where the height is 0. Press enter. It says I'm going to look to the right of that. I'm going to go to the right of where it crosses 0 and press enter. My guess, put as close to that as I can, and it finds that x equals negative 1. X equals negative 1 was one of the answers I already had. This is just a way of double checking to see if I've done things right. Now, I have to check my solutions. One answer was x equals 6, and one answer was x equals negative 1. How do I know if these answers work? Well, the first test I do for these particular questions is check to see if it makes my log negative. So I'm going to plug 6 into that. I get 2 minus 6, which is negative 4. And knowing that I cannot have a negative in my answers, I know I have to reject the negative 6 from my answer. That calls it an extraneous root. Or I could simply just say I am going to reject that answer. Now, it doesn't mean that the negative 1 automatically works. I'll try plugging negative 1 into here. 2 minus the negative 1 gives me a 3. 1 minus the negative 1 gives me a 2. And negative 1 plus 4 gives me a 3. Now, what is log base 2 of 2? 2 to what power equals 2? The answer is 1. So this and this are equal. What about the other pieces? This is log base 2 of 3, and this is log base 2 of 3. So this answer does, in fact, work. Now, I see I need another 2 minutes worth of time. So let's see if I could find, let's say, a simulation site in physics. Physics simulations from PhET, one of my favorite simulation sites. Looking for a physics simulation. Light, nah, I'll go electricity, magnetism. Looking for circuits, because I'm just doing circuits or just finished circuits with my physics 12 students. Let's see if we can find, grab a wire, grab the wire, put a light bulb on it, grabbed another wire and connected it. Another light bulb for fun. Another wire. Let's give it some power. Another battery. Another wire. And we have this circuit completed. I could do lots of wonderful things. I could grab a voltmeter and check out the voltage drop across that resistor, 4.5 volts. What do you think the voltage drop across both resistors might be? 9 volts. Wonder what the voltage of the battery is. I would say 9 volts. What if I want to change the voltage? Let's say make the voltage 12.94 volts. What do you think the voltage drop across one resistor would be? About half that. The whole resistor, 12.94 volts. Let's say I want to try an ammeter. Where would I find an ammeter? I pull it out. Hook that back up. Oh, I'm out of time. Let's